Hello everyone. Now let's discuss about a binary adder and subtractor. So before that, let's look into a few prerequisites like how to convert a decimal number to binary and how to perform normal binary addition and subtraction. So given a decimal number, to convert it into binary, we factorize the given number with 2. So for example, let's take a decimal number 5. So to convert it into binary, we factorize it with 2. So we'd get 2 twos are 4 and 1 is left out. And again, 2 ones are 2, nothing is left out, so it's 0. And we consider the numbers from bottom to top. So 5 in binary is 1, 0, 1. So this is how we convert a decimal number to binary. Now let's see how to perform binary addition and subtraction. So to perform binary addition of and subtraction of two numbers, we follow the rules, and these rules are mentioned over here. So let's take an example. Let's add two numbers, let's say 5 and 7. So 5 in binary is 0, 1, 0, 1. I'm taking a 4-bit binary number. And 7 in binary is 0, 1, 1, 1. So these are the rules we are using for addition. So 1 plus 1 is 10. So 1 is taken as carry and 0 as a sum. And 1 plus 1 is again 10. So 1 is carry and 0 is the sum. 1 plus 1 plus 1 is 11. So 1 is carry and even the sum is 1. 1 plus 0 is 1. So we get a 1 over here. And 12 in binary is 1101. So this is how we perform binary addition. Now let's take a look into binary subtraction. So for binary subtraction, let's take 5 and 3. So 3 in binary is 0, 0, 1, 1. For subtraction, we use these rules. So 1 minus 1 is 0. 0 minus 1 is a borrow. So we take a borrow from 1. So 1 is reduced to 0. And 2 is, 0 is 2 right now. So 2 minus 1 is 1. 0 minus 0 is 0. 0 minus 0 is 0. So 2 in binary is 0, 0, 1, 0. And this is how we perform subtraction of two binary numbers. But borrowing is a very difficult process. So we have two other methods for subtraction, which are one's complement and two's complement. And even in one's complement, we get borrows. So we go for two's complement. Now let's see how to perform subtraction of two binary numbers using two's complement. So I'll consider the same example, 5 minus 3. So we take the 2's complement of 3 over here. So the 2's, so generally 3 in binary is written as 0, 0, 1, 1. And its 1's complement would be 1, 1, 0, 0. We already know that 2's complement is nothing but 1's complement plus 1. So we just add 1 to this and we'd get 2's complement of 3. And the result would be 0 plus 1 is 1, 0, 1, and 1. And now we perform normal addition. So 5 in binary is 0, 1, 0, 1. And the number we've got over here is 1101. So we have to get the result as 0, 0, 1, 0. So let's see what happens. So 1 plus 1 is 10. 1 and 0. 1 plus 0 is 1. 1 plus 1 is 10. So 1 is a carry and 0 is the sum. And again, 1 plus 1 is 10. So in 2's complement, we neglect the carry. So this is our result, 0, 0, 1, 0, which is 2 in decimal. So this is how we perform binary addition and subtraction. Now let's see what is a full adder. So full adder is an adder of 3 inputs and it gives out 2 outputs. So let's see this with help of an example like 1, 1 and 0, 1. So I'll consider 1 and 1 as A, 1 and 1 as A, 0 and 1 as B. Okay. So initially my 1 is 1 and my B is also 1. And over here, as we have no carry, our carry in would be 0. So A plus B, that is 1 plus 1, would result in 1, 0. That is our carry is 1 and sum is 0. So our carry is 1 and sum is 0. And in the next step, our A is 1, B is 0, and the carry in is 1. Again, 1 plus 1, 1 plus 1 is 10. So we've got sum 0 and count 1. That is 0 and 1. So in addition, the carry out is placed at the MSB position. So this is how a full adder works. In a binary adder and subtractor, we have 4 full adders. So with help of 4 full adders, we construct a binary adder. Let's see how to construct a binary adder. So first let me draw the 4 full adders. So every full adder has 3 inputs. So this would be my A naught. This would be my B naught. This would be my A1 and this B1. This is A2 and this is B2. This is A3 and this is B3. And all of these are our full adders. So as I told, every full adder will have 3 inputs and 2 outputs. So the other input, so we already have 2 inputs over here. So the third input will be C naught. And the first output would be S naught. And the next output would be C1, which is the third input of this full adder. So the output of this full adder is an input to this full adder. And again, we get S1 from here, and C2 would be the input for this full adder, and we get S2, and again C3 is input for this, C3, and this is S3, and this is C4. Now let's take example of two numbers. Let's take 0100 and 0101, which are 4 and 5 in decimal. So my A naught would be 0, my B naught is 0, A1 is 0, B1 is 0, A2 is 1, B2 is 1, A3 is 0, and B3 is 0. Now let's perform the addition. So initially there is no carry, so C0 is equal to 0. So 0 plus 0 plus 0 would result sum 0, and carry is also 0. Again 0 plus 0 plus 0. So one second, let's write this down over here. Again 0 plus 0 plus 0 would result in sum as 0 and carry also 0. So we get a 0 over here. And then 1 plus 1 plus 0, we get a carry 1 and sum 0. So we get a carry 1 over here, and sum 0. And now 0 plus 0 plus 1 would result in 1, and carry is 0. 1 and the carry is 0. So 4 plus 5 got us 8. So this is how we perform binary addition. Now let's look into binary subtraction. So this is the common diagram for both binary adder and subtractor. So over here we have an external switch M. So the value of M differs for addition and subtraction. So for addition, the value of M is 0, and for subtraction it is 1. Let's see this with help of an example. First, let's subtract two numbers. I'll take 5 and 3, as we've already done that. So 0, 1, 0, 1. And 3 in binary is 0, 0, 1, 1. These are my A values, and these are my B values. So 1, 0, 1, 2, and 3. So my M is initially 1 because we are performing subtraction, and M is always equal to Cn. So Cn in this case would be equal to 1. So Cn is 1, and our A naught is 1, and B naught is also 1. A1 is 0, B1 is 1, A2 is 1, B2 is 0, A3 is 0, and B3 is also 0. And M is 1 in all the cases. So 1, 1, 1, 1. So here we have an XOR gate between uh, B and M. So when we perform XOR operation for 1 and 1, we get the result as 0. 1 and 1 again, we get 0. 0 and 1, we get 1. And again 0 and 1, we get 1. Because XOR gate is an odd one detector. Now let's perform addition. So 0 plus 1 plus 1. 0 plus 1 plus 1 would result in 1 carry and sum 0. So 1 carry and sum 0. And again 0 plus 0 plus 1 would result in sum 1 and carry 0. So here we get the sum as 1. And again 1 plus 1 plus 0. 1 plus 1 plus 0 is again 1 as a carry and 0 as a sum. And 1 plus 0 plus 1 again. 1 is a carry and sum is 0. So the final output we got is 0, 0, 1, 1. So that is the output we get when we subtract 3 from 2. So 5 minus 3 is 2. This is how a binary subtractor works. So this is a binary adder and subtractor. Thank you.